This is the work solution for mechanical science sheet 7 question 2. So we have a cannonball and it's projected from a point 30 degrees from at an angle of 30 degrees from the ground with an initial speed of 60 meters per second. So basically we do a triangle like this with a 30-degree angle. This is a right angle triangle. So there's a vertical component and a horizontal component. The vertical component we'll call UZ and the horizontal component we'll call UX. So the sine and cos of this triangle, if we do the total velocity, which is 60, multiplied by the sine and the cos of the angle, we'll get each of these velocities. After that, we can say that we have a maximum height when the velocity in the z direction is equal to 0. So if we get this equation, v equals u plus at, and plug in our value for uz and our acceleration, which would be the acceleration due to gravity, and we can rearrange for time t, bearing in mind that that v on the left, this v here, is equal to 0. So we would essentially have uz is equal to at. Oh yeah, just like we've got here, uz is equal to at, and then we can rearrange to get t as uz over a. That should say uz, but yeah. So the previous question was how long does it take to reach the maximum height, and now we're actually solving for the maximum height. So we use this equation, v squared is equal to u squared plus 2as, and just as before we set v equal to 0, so it ends up to be u squared is equal to 2as, and we just rearrange to solve for s. The third part of this question asks you to find the total time of flight. To find that, you basically take the time that you solve for on part A and add it to the t it would take to go from the maximum height to the ground with an acceleration equal to g and initial velocity of 0. So I'll just leave that for you to solve. And part D, you're asked to find the total range. So you can just multiply the time of flight by the initial velocity in the x direction.